Hello everyone and welcome to another video. In this video we're going to focus on a few more shapes and commands we can use. This will be primarily a triangle command, the quad command, which allows us to make four-sided polygons that are not necessarily rectangles, so we call those quadrilaterals. And the last one will be the arc command, which is very similar to the ellipse command in that we can make a curve around the shape of an ellipse, but the difference is we can not draw the whole thing. So instead of closing off the shape, we can make arcs that are partially completed. We can fill them in, we can not fill them in. We can do all kinds of things with that command. And then we'll see a few other ones that allow us to kind of disallow certain things. So for example, the ability to not draw an outline on a shape if you don't want it, or to make the shape hollow, meaning there's no color on the inside, which is also useful if you want to do kind of like wireframe type things. So we'll try these different things out in this video. Let's go ahead and make our canvas 600 by 600 so we have a little more space to work with. And there it is with our default background color. I'm going to start off with a triangle command. First, as always, let's go ahead and pick our colors. And what I'm going to do here is I'm going to introduce this first new command. I'm going to make the triangle a color. I'm going to make it a bright green or a green color, maybe not necessarily bright green. So we're going to do fill, which if you don't remember in the last video, fill is the inside of the shape as opposed to stroke, which is the outside. So I'm going to say no red, a good amount of green, and no blue. So that's not super bright green, but it's a green color. And now here's where we have something new. By default, if we don't put stroke, it gives us a black outline, right? And then if we use stroke weight, we can make it thicker or thinner based on what we're using. But in this case, what we want to do is I don't want to have that outline at all. And so the command I'm going to use is kind of like a partner that goes along with stroke, but instead of using stroke, you use this one instead. And in fact says no stroke. And you can see how I spell it lowercase n capital S. And it says, look, if you do this, it is a command, so it does need those parentheses, but you're not going to give anything inside of them. You're going to leave them empty. And you can see it looks like that. You're saying, look, when this is drawn, do not put an outline, even the default one. So if you want shapes that are smooth and don't have those lines around them or colors around them, then you can very much, I mean, you could, I guess, use stroke with the same color as fill, but that would also change the width of the shape, whether we would know it or not, because that outline is part of the shape, and it would maybe not look things flush. Things wouldn't look flush if you tried to do that. It might be a little bit more work. And so instead, we say, you know what, no outline at all with the no stroke command. And then now finally the triangle. So the triangle command requires 3 points, right? Those are the 3 points of a triangle, and it will automatically draw the edges between each of those 3 points. And what I'll say is it needs basically 3 sets of x and y coordinates. It requires 3 x, y coordinate pairs, right? The order in which you do them does not matter as long as you go in one consistent direction. So I might choose the top point first, and then the bottom right point, and then the bottom left point. And even that description is maybe not true because the triangle could be almost anywhere. So it could be like a point that's on the top left, and then a point that's straight below it down, then another point. They don't have to be right triangles or isosceles triangles or anything. They can be any three-sided polygon, really, which it becomes a triangle. So it's just a matter of placement. As long as you go in an order and don't kind of pinch them by putting the same coordinates, then you'll get the shape, a shape that is a triangle of some form. Right? And so if you want a nice even-sided triangle, then that requires a little bit of thinking in terms of the math of like, how are these things mirrored in terms of their x and y coordinates. And that definitely is something that can be done with a little bit of effort on our part. So let's start off. I'm going to do this triangle command now that it has a color and no outline. And so that first xy, I'm going to maybe put it right in the center. So I'm going to do the center of my thing, which is 300, 300. So there's my first xy point. My next xy point, I'm going to make it go down and to the left. And so down to the left, so if you think about our triangle, I'm going to say go down how many pixels? Let's say if I go down 150 pixels from where I'm at in terms of the, actually we're doing width, I'm sorry, first. So the direction, are we going to go left or we're going to go right? I want to go left about 100 pixels. So that would make this at 200. So if we're at 300 and we go left, that's like subtracting. So that's 200. If I want to go down, that's like adding to the y, and I want to go down 150 pixels. So that would be 150 plus 300, which is 450. And then now the last point. If I'm thinking where I'm at, where would this third point be? If I want it to be symmetric, if the original top point was at 300, 300, and we went down to 450, that shouldn't change. If it's going to be parallel and lined up with the left point, then that's not going to be different. It's only the x that's going to be different. If the left point went 100 to the left, so that's made this 200, then the right point went 100 to the right, then that would be adding. So it should be 400. And then the y should be the same because, again, I went down the same amount. So let's go ahead and see what this looks like. And I think that we did this correctly. And if we did, we should see a triangle show up. There it is. And there it is. You can see. So again, visually, what we did is we said, well, go 100 to the left. So that's 100 to the left. And then go down 150, which is here. So that's that 200, 450 point. And then in a similar fashion, for the third point, we said, well, okay, go to 400 in the x, which means go all the way to the right, which is 100 away from this one. So there it is. And then we went 450, which we were already at 450. So that's why it's a straight horizontal line. So there's our triangle, right? And notice there is no outline. If I get rid of this line, no stroke, we can see that it puts that black outline by default. So the no stroke is useful if you do, in fact, not want to have any outline. So it's kind of like a counter to the stroke weight. You don't want to have any outline, then you can do that. Let's play with these numbers just to move the point. So I'm going to move this thing just maybe to the left. So I'm going to change this one to be, I don't know, 137. If I run it, you can see there it is. So the reality is that you can make any triangle by moving any of the points, right? So if I change this one from 450 to 375, I run this one, there it is pinched. So you can see you can make any triangle with 3 points. Now you have to be careful. If you overdo it, if you overlap them, that can cause problems. I'm going to move this point right here. Let's move it somewhere over here. So it's going to go more to the right and then up a bunch. So I'm going to say, let's move to the right, let's say 325. 325. And then I'm going to move it up to, this one is at 300. I'm going to move it a little bit below that. So let's do 325. 325. Let's see what it looks like. And there it is. So now this one, so again, you can imagine like the triangle flipped. But what it is that, again, it is just 3 points, and those 3 points are connected with edges. And then if we have a fill, it does in fact fill it in to close that shape. So again, we have a lot of control. It's just a matter of kind of visualizing where. If you drew this on a piece of paper, it would be useful and say, okay, I want this point. So as long as you know which one is higher, you know which numbers are smaller. As long as you know which one is to the left or right, you know which numbers are bigger or smaller. So this is useful to have for us. So now let's go ahead and try doing a quad or a quadrilateral, the same exact premise as a triangle, except now there are 4 points. So that means there are 8 inputs, right? So because there's 4 pairs. Here there are 6 inputs because there are 3 pairs of x and y. A quadrilateral or quad requires, quads require 4 xy coordinate pairs. Right, so it's just the same thing, but more. And so I'm going to go ahead and change the color. So I'm going to say, in fact, in this case, I don't want it to have an inside. I want it to be hollow, but I want it to have an outline. So I'm going to say stroke. And I'm going to go ahead and do maybe a blue outline. So no red, no green, and then blue. So a lot of blue, the maximum. And then I'm going to say, now again, if we have fill for the inside color and we have no stroke for no outline, then the reverse would be we say stroke for the outline and then no fill, which is our new command for the no inside. And now our command quad, and this is again, this is going to be a matter of what I want to draw. So I'm going to put a 1 point somewhere up in here. So I'm going to say, if this is 600, we'll go to the left a bit. Let's do 475. And then if I want to be relatively close to the top, if this is 0, then we'll go maybe down 100. So that's my first point. And here the order is really important. Either go clockwise or counterclockwise, because otherwise you might end up with the points in such that they end up twisting and you end up with like a flipped or like a pinched shape where it looks like 2 triangles are touching at the tip. So we have to be very careful with that. So my first point is there. My next point, I want it to go down a bit, so my y should get bigger. And I want to go to the left a bunch. So instead of 475, smaller than that to the left would be maybe 400. I want to go down a bit, so let's do 175. So that's going to be down and to the left. Let's try going to the right a lot. So if this one's at 400, the next one, let's say, is at 525. And then I want it to go just up a little bit, so somewhere between 100 and 175. So let's do something like 140. That's my third point. And then my last point, I want to kind of put up and away. So I'm going to move it upwards so that the y should get smaller. So I'll put it to, if the first y is at 100, I'll put this one at, let's do 75. And then if this one is at 525, I want it to go in a bit, so let's try 500. And again, I know that's maybe a little confusing, and I didn't draw out the picture beforehand, but the reality is, as long as we know where these points are, the result is it'll draw the lines between them. So here we go. Ooh, so I definitely messed up. I was thinking way too much in terms of x and y's, but you can see this is the problem. You have to know your points, otherwise you end up with a very odd shape. So you can argue it looks like a triangle, but it's actually a four-pointed thing. So let's go through this again. So 475, 100, that's, I believe, right here. 475 is very much to the right. The 100 is right here. My second point is at 400, so that's somewhere further to the left, and then 175 is much, much lower, so I think that might be right there. That looks good. The next one's at 525, which is more this way. Ah, there it is. I can see it's my last number that I screwed up. I believe I flipped them. The x should be much more to the right, and then this one should be very, very high. So I flipped these two numbers, I believe. So let's take a look now. And there it is. In fact, something's off because I have two numbers that are matching, and that seems off because we should see a fourth point. So let's make sure they're not in line with each other. So 475, 500, let's do 535. Let's see. There we go. There we go. Now we can see that they're not. I happened to pick the exact number that made the line almost perfectly straight, but now we can see that it is in fact a four-sided thing. And if I move this one maybe down a bit, so I'll lower this one to 125. So you can see that now it's almost straight, but it bends inward, so I can do even more. So let's do 145 and see what that looks like. And there it is. So you can see we can make almost any quadrilateral shape, because again, it's a four-sided polygon, but it doesn't have the strict requirement of a rectangle that it must be parallel sets of parallel lines. So I can use this in conjunction with a triangle to make all kinds of advanced shapes. Our last shape that we're going to do, and this one is a little confusing just because it has some new things that require information that's needed to work, is what we call an arc. In terms of behavior, it's very similar to a ellipse. So let's try doing that. We're going to say arcs require an x and y, center coordinate. So this is just the center, just like an ellipse. They do require a horizontal and vertical diameter. So horizontal and vertical diameters. And then the last thing, which is new, and I'm going to go ahead and go to the reference for the arc just so you can see it, is we have to tell it, well, what degrees should we draw of our arc? So you can notice that here there's a bunch of different arcs. There's one arc that goes from here to here, one from here, and so on. And then in this example, they show how you can do different closings of arcs based on what properties you want to have. But the idea is that we have a lot of abilities, and it gives you, again, the references are fantastic because there's just so much stuff to them. I'm going to go ahead and stick with just looking at the first one. And what I'll say is, realistically, I'm sure most people are not necessarily in math where they've learned radians versus degrees. You might have a sense of it. You might have a sense of the circles and how degrees work with them. But if you don't, we'll make this very easy for ourselves. And we'll simply say, let's make the computer do the heavy lifting of converting radians, which technically is what it uses to figure out circles, to degrees for our purposes. And we can just think, a circle has 360 degrees, and I want the degrees from one number to another number to be filled in, and that's my arc. So let's try doing that, and then we'll say a starting degree and ending degree of the arc. Right, so this is complicated, but not too much more than the ellipse. So I'm going to do the same thing. I'm going to pick colors, so I'm going to say fill, and I'm going to go ahead and put 75 red, 170 for green, and 40 for blue. And then I'm going to go ahead and now I'm going to do stroke, and I'll just put 0 so it's a black outline just to make sure that it's black. And I won't make the stroke weight any heavier right now. I'll just leave it the way it is. And so here's our command arc. So we start off just like the ellipse. We say, okay, where's the x and y? I'll put mine somewhere in the top left. So I'll say something like, I don't know, 75, 75. My width and height, I don't want it to make them too big because I don't want it to go off screen. And I'm going to go ahead and say, I'll make a circle to start, and then we can see how we can work this afterwards. And so I'll do 75 and 75, so that's not too big. And now, so this is the same 4 points that our ellipse had, right? The x and the y coordinate of the center, and then the diameters, both horizontal and vertical. And here's the new thing. In the reference they refer to radian values, which is a little more complicated. And so instead of doing that, we're going to kind of be strategically lazy and say, can we convert, I want to give a number that's a degree, so between 0 and 360, or some other numbers, but just as regular numbers, and have it automatically converted for us. And there is, in fact, a command that does this. Now we can see if we go to the very bottom of our reference, there are some, I think maybe there should have been some useful outline examples. But if not, we can go here, and we can look for our degree and radian. I'm going to go ahead and search for it. So we'll do degrees and radians. That's not it. This is it. This is the one I want. So radians command, and radians command, you give it a degree as between 0 and 360, and it gives you the radian. And again, if you don't know what those are, for our purposes, really, we're just thinking, okay, between 0 and 360, what does it look like? So we're going to say radians, and then my starting point, I'm going to say 0 for this one, and then radians again, and then in the parentheses for that one, I'm going to go ahead and say 180. So I'm going to claim, I think, that this is going to give us the bottom half of a circle. And let's see what that looks like. And there it is. So bottom half. And so some things to note is, one, the part that's automatically closed for us is not closed off with a line, and so that's definitely one thing that doesn't look great. So it looks kind of like an open fruit or something like that. And another thing we have to recognize is the direction that the arc happens in degrees is clockwise. So this was 0, and then we went all the way to 180 degrees. So that's a complete turnaround. We can prove this by changing it. So if I do 90, that's a quarter. That's 90 degrees worth of a circle. And now I'll do one last thing, is if instead of doing fill, right, if I comment this out and I say, you know what, let's do no fill, this is how you can get an arc that just looks like a line. And this is actually really useful. That is a very useful thing. And so now I can play with these. And now I'm going to do the final step of manipulating the diameters, and then now instead of being a nice perfect circle, we could do something like, let's do 150, or just double. And now you can see we have a stretched curved arc. And if I did this one as like, let's do shorter, let's do 30, then it would be an even thinner line. So now we can use this to manipulate it and make all kinds of arcs and shapes, and we can use the fill or no fill. And I'm going to put this fill back in just to see what it looks like. And we can see that it does kind of fill that in. And I'll point out the last thing we can use is these properties, and it mentions, you can say what kind of details do you want. We have open, we have chord, and we have pi, and so I think we'll go ahead and stick with the default. It says, let's see, open semicircle, I think that's open. Let's try chord and see what chord looks like. I don't remember, so let's see what chord looks like. So after our radian, we'll say chord. I think this is what's going to happen. There it is. So chord basically says, okay, I'm going to draw a straight line between the two endpoints. So this is hard to see, so I'll go ahead and make this back to a circle. So 75 and 75. And there it is. So we have a chord of a circle, but then it looks odd because it does a straight line. So chord I don't particularly care for. I think pi might be the better one. So let's try pi. Pi is the one I like because what it does is it makes sure that the open edges, if there are any open edges, get these stroke things. So that's convenient. And the default, I believe, which was open. If we leave it how it was, that's the default behavior. Actually, no, that is not the default behavior. You notice it's very much like chord, but it doesn't have the line through it. So I guess there's another one that's the default. I wonder what it is. It doesn't give us a name. But I guess if we don't put anything at all, then it's a default. And that's what gives us. It's kind of like the pi, but without the line. So if I get rid of it altogether, and let's go back to how it was, we can see the difference. And there it is. So this is like pi, but pi puts the outline. So I like pi. I think it closes it off. If you're going to do like a quarter chunk. And then what we could do is we could say, well, okay, let's do pi. It has to be all caps. And then let's do no fill. So no fill. Let's cut that out. And now we have a hollow. Notice the background is whatever color the background is. So if I change this by making this darker, so I put 100, you'll see that it's still hollow, and there it is, right? So the idea that's nice is that this thing is hollow, and you can do this with shapes. And any shape that is closed, you can use no fill, and that'll make it like a hollow thing, right? And let's go ahead and just kind of play with the numbers a little bit. Let's put this one at 200. And there it is. We don't have to always start at 0. So for example, I could start at, and we should do them in order, so I'm going to start at maybe like 85 and end at 200. And there it is. It's kind of hard to tell because of what this is, but there it is. This is 85 degrees, which is almost 90, and then it curves around to 200. And again, remember, this is not a perfect circle. This is why this line looks odd, is because this is not a perfect circle because the diameters are different. So we can really, and if I get rid of the pi, I think this looks even better as a line. You can see that I can make an arc in almost any direction and any shape by blending these two things together. If I made this thing wider, then it would be a little bit more stretched out, and it would look more like a curve, right? So we can get away with a lot of different things with this. It's a matter of playing around with it. If you're unsure, you can look at the reference. It gives you all kinds of wonderful examples and extra details that you might need to make this happen. So we'll stop here in this video for today.